how DSC should be treated, how conflict management should be done, and how you can integrate DSC into a release pipeline concept. So my name is Raimund, or first of all, the important sponsors, the mandatory slide. Then we have some information about myself. I'm a PFE at Microsoft Germany since quite a long time, since 2002, and my main areas are everything around DevOps, DSC, PowerShell, and automation. You can find me on Twitter and on GitHub, of course. And the agenda for the upcoming 30 to 45 minutes is this one here. First of all, we want to give you an overview about DSC. How does it work? Then how can a change be described? So how can we do config management in DSC in a pretty proper way? Not like it is documented in the basic principles on the Microsoft page, but with more tooling around it. And finally, how can we deliver the change? And this gets then into a CI/CD release pipeline. Because timing is a problem here, this talk was designed for a 90-minute talk, we have to switch the order a little bit. So we start with the more important part, which is delivering the change, then describing the change, and then if there is time, then we are going into the DSC details. Because I think, or I hope, that most of you know how a DSC is and how it works, or may not work. So who is using DSC in a production environment? Wow, that's an interesting number, yeah? Okay, so let's see how much you can gain from what we are going to show you. First of all, the previous slide was about the credits. So this is based on the work of Gail Kohlers. This is the organizer of the conference. Michael Green and Steve Murawski, and everything these guys put together can be found in the white paper, which is the release pipeline model. It's pretty old, but unfortunately still not very known, and especially the knowledge in there hasn't been adopted by not many enterprises so far. Good. So let's go into, as I mentioned, we're changing the order a bit. Let's go into delivering the change. And first of all, so what makes a solution a good solution? Adaptability, so we need to have a solution that can be changed to new circumstances. It needs to be predictability and reliability. And if we think about change management, so who thinks he has a change process that is 100% reliable and predictable? So how do you guys do change management normally, right? So you have an idea of what you need to change, you have a requirement, you put this requirement into some kind of database, this gets to the change board, some people have to look at the change, and then you have to go do it more or less manual, right? So this is how it should actually not be done, at least not if we come to a DSC or an infrastructure as code world. We have or pretty often if it comes to changes, the single point of failure. So you have the one guy who knows really good about the environment, who knows how the technology works, and especially if it comes to PowerShell, we have only a few people in a company that know PowerShell and the related technology very well, like only one or two people who knows very well Active Directory and PowerShell to automate the stuff, right? So then we are coming to the bus factor. Maybe you've read the Phoenix project and Brent, so this is the guy everybody comes to, and if this guy is hit by a bus, then we have a problem, because nobody else except for Brent knows how a change can be effectively put into our environment, right? Then we have the problem of collaboration, traceability. So if you want to go back in time, let's say a couple of months, how do you know what changes have been done to your environment in January and February? How can you look up the changes? How can you find certain keywords? Usually changes are not indexed very well, right? So kind of tracing back a change, tracing back a problem is in the classical way of change management very, very difficult. Then we have the problem of knowledge sharing, which comes then also to visibility. So how is the change put into a database in a way that other people can find it, related to some technical issue, related to other changes, right? So if we would have our changes all in a Git database, handled in the way that we all handle documentation, text, source code, and so on, it would be much more traceable, visible, and would foster also a climate of collaboration. And the problem here is, or the very important quote is, from Goldratt, any improvement not at the constraint is an illusion. And in change management, the biggest constraint is us, the humans, right? So we do not deliver the change maybe as we should have done. We have not the best mood in the morning and doing the change slightly different than previously tested in the test environment, and therefore the change is not exactly as it should be. So how can we improve this? Usually we need small changes. And just last month I was with a customer who had a change already open for a certain Active Directory implementation. And we discovered something that we needed to change, and he said, okay, we have a change already open, let's put this into the already existing change, even if it is not really related to that, which is not the way how it should be, right? Every change should indicate a small and precise change in the environment and not be a kind of summary for even not related items. Versioning, traceability, right? Another thing. So has anybody of you found a concept of versioning a server, which means if we have a problem and we want to relate the problem to some configuration state, then our server should have a certain version number so we can look up the configuration database and kind of match this. Has anybody managed to assign versions to server machines or to whatever machines? No, right? Yeah. So infrastructure as code is helping with that. Then visibility, we talked about that already, right? All changes should be in a Git database, so then it makes it also quite easy for other people to see what's happening in our environment. I mean, it shouldn't be kind of a secret what is changing in the environment, even if it is not my personal space or my technical space I'm working in. I should be also able to see changes happening in other technical spaces. This leads us to openness and accessibility. High cohesion, low coupling, we talked about this. We want to only have technical detail in a change that is really belonging together. So we don't want to do changes that are reaching out into other environments. And finally, we want to have a frictionless to change. So the change has to be delivered in various environments without any kind of trouble, without friction. And this is usually, especially if it comes to a normal enterprise environment where you have a dev environment, a test environment, and a prod environment, pretty much impossible. So what we usually do is we are developing the change on our personal box, on our dev environment, and to make sure that it's not completely wrong what we are doing. And if we have proven that it's not completely wrong, then we are moving the change into our test environment, and from there to the prod environment. And every time we're moving to a different environment, we are adding some kind of trust, because we know that things are working as expected, right? But this trust only makes sense if the outcome at the end, at the very far right, is really exactly the same as we put in on the left. And this is not happening, because we're all humans. So we all do our work slightly different depending on our mood, on our personal situation, on our focus. And therefore, even if we think we have added trust, at the end the outcome might be slightly different. And here we are talking about a promotion of trusted changes. So we are adding trust and we are promoting this change to the other environments. This is the classical way how usually an infrastructure is managed. Okay, so if we are talking about infrastructure as code, about DSC, then we want to give this change a different format, and then we are talking about an artifact. So what is an artifact? It's coming from the Latin word arte and factum, so something has been made by hand. And if we think about an artifact in the IT space, then it is something that, a unit or entity, something created by us, and it's versioned, it's tested, and the most important thing, it's immutable. So think of Notepad++, you download a Notepad++, you're testing it on your dev environment, and you can be sure that nobody is changing Notepad++, the Notepad++ MSI, because if it would be possible to change it, then there is no trust in all, because you have no idea after the change is the version number. Of course, it's not the same version number. As soon as something happens to an artifact, the version number needs to go up. So a change to an artifact would completely break the trust, right? So these are the things that describe an artifact. And if we are thinking about a change also as an artifact, then we are no longer promoting by hand a change from left to right, but rather we are creating an artifact which is usually created in a release pipeline. And this artifact is then promoted by a release pipeline to the other environments, which guarantees that whatever the artifact was in the first place is also the artifact that we are actually applying in the prod environment. And this is also the only guarantee that gives you a chance to have many environments in absolutely the same state. So I've been with many customers who had tried to have a dev, prod, and test environment in the same state, but they all failed because they do the changes manually and there's no guarantee that the change has been promoted in the same way to all 3, 4, 5 environments, right? But if we are using a release pipeline, then that's the guarantee that whatever is applied to the dev environment is the same that is being applied to the prod environment. So the magic is we have an artifact, the artifact contains the change, and the artifact is promoted to, or in rings or in stages, to my various environments. Good. How are we creating artifacts? So many of you are using DSC already. Are you also using DSC in connection to a release pipeline, or is it more or less a manual process how you do this? Okay, who is using DSC without a release pipeline and having scripts to push things around? Okay, yeah, so hopefully that helps. Yeah, so if we are thinking about the release pipeline in a PowerShell module release pipeline, then we have this quote here from Mr. Schwartz: "The pipeline applies its rule in a rigorous, unemotional way." So we have defined the pipeline just once. We have a process where we have defined how we want to promote our artifacts or create our artifact and then promote it to the various environments. And this happens always in exactly the same way. So regardless of my personal mood, my situation, my tiredness maybe in the morning, this always works the same. And that guarantees me that the change is actually being in production as we want it to be. And let's move forward from that one to a more complex scenario, which is, this one actually. So, in DSC, we have a configuration, which is just the setup of various items that I want to configure, like services, files, and so on. And we have configuration data, because we want to configure the number of files, the number of services, whatever. So this information goes into the release pipeline, and we know that in DSC, especially if we are working with pull servers, we have a number of artifacts. It's not just one artifact. We have the MOF file. The MOF file is containing the instructions. And it doesn't matter if we have DSC on-prem, if we have Azure Automation DSC, or even in guest configuration, the principle is still the same. We have an instruction file. And this instruction file needs to be created somewhere. So this is one result of the pipeline. The other one is the checksum file. So to make sure, or to give the client or the server an idea if something has changed in the instruction file, we have a checksum file. Then we need to have the metamorph file. The metamorph file is configuring the DSC engine, telling the DSC engine where the pull server is and where to get the information from. And finally, we have the zip modules, because as we know, DSC resource modules are important. This is the abstraction layer that takes the instruction file and actually does something to the machine with that. So we need to have all these artifacts, and the release pipeline needs to create them and puts them into the right location. And the right location is the pull server. And another thing is that we want to have, every change should have a limited change scope. So that means all the resource modules are of course not a product of my release pipeline, but the resource modules have their own release pipeline. Right? You can find them in the DSC community on GitHub, and every resource module has a predefined release process. And finally, we have an artifact on the PowerShell gallery that you may not want to pick up in your release pipeline, but what you do, you take this module and you republish it in your personal NuGet repository or on-prem NuGet repository. Yeah. So that's roughly the release pipeline that we have. And it's all a bit more complex, and we need to think about one fundamental part of a release pipeline, which is the feedback loop. Because if you do a change process in a manual fashion, where is the feedback process or the feedback loop? Usually you test your stuff, you see something breaks, that gives you an idea that something is not as expected. But are you always looking for all the things that can go wrong? Are you always testing for all the things that can go wrong? Usually, even not in a release pipeline, but even less if you do things manual. So there is no feedback loop or no effective one. So here we need to have one. So I think you all are familiar with Git. So every development process starts by cloning a repository and doing your changes locally. And before you are pushing your changes back to the repository, which means before you are, do we have zoom it somewhere? We do. Before we are going to push the changes from local to my source control system, I'm testing if the build can be started locally. So if my software doesn't build locally, there is no meaning in pushing it to the repository. So this is the first feedback I have. The second feedback is, as soon as I am pushing something to my repository, CI/CD triggers a build and gives me some feedback if the build could successfully be completed. And only if the build completed, then we are going into the next process, which is the test process, right? So then we are testing our stuff, and if this happened successfully as well, then we are going into the deployment phase. And this all happens automatically, so I don't have to kick off anything manual in order to make sure that my change is as expected. And we will see in a minute in a demo how this actually works and looks like. And finally, if we have figured this all out and the tests are fine, then we are in the release stage, and the release stage is also part of the feedback loop. So we are releasing into dev first, and then we can trigger some tests in the dev environment, making sure that everything is working as expected. Then we are going to test. And finally, we have usually a manual approval process. If the test is green, then we are able to go to our prod environment. Good. So how does that look like in how does that look like in production? So here we have an environment which is these machines. And by the way, all the resources to create exactly the same environment that I have here and to kind of play through the release process is available on GitHub. I have a slide at the end with the references. And there is also a script that is creating this environment for you. So if you want to play with DSC in a sandbox, you don't have to create all the stuff manually. The script is giving you a domain controller, like this one here. It is creating another machine which hosts a SQL server plus a certificate authority, because security is important in DSC. Then we have the Azure DevOps server. And finally, also a pull server that is be able to host the MOF files. And the DSC hoster one is the last extension that we have added to the lab. It spins up test machines, makes sure that everything works in the dev and test environment, and then destroys them afterwards. So it's just a nested Hyper-V to make sure that whatever I have put into my instruction file actually works. And to demo how things work, I'm opening here my Visual Studio Code. And this is the DSC solution that looks pretty like every module that you're creating with a scaffolding tool called Sampler, also created by Gail Colas. And in our source folder, we have not PowerShell files, as you would expect in a PowerShell module, but here we have a bunch of YAML files. So the ones of you who are using DSC in a production environment, how do you manage your configuration? In which kind of format are you storing configuration data? PSD1, okay? How many PSD1 files? Pardon?
One per server.
One per server, okay. So one PSD1 file per server. That comes with a downside that if you have, let's say, 10,000 servers, you have 10,000 PSD1 files with, I guess, a lot of redundancy, right? So this concept is more a hierarchical data structure. So we can have roles, baselines, environments, and so on. Especially if you are thinking about having 3 different environments, then you want to be able to define exceptions per environment. Let's say we have a different IP scope in the dev environment and different credentials for sure in the dev environment than we have in the test and prod environment, right? How can we have a common configuration, a common scenario with differences per environment? Or how can we put all similarities of file servers in just the file server role, right? So I'm not sure if we have the time to have a look at this later. But if you think that this concept of dealing with YAML files is something interesting, then have later a look into the DSC workshop. And here we have the exercise folder. Exercises, there it is. And there are 3 tasks. Task number 1 is more or less a recap about the DSC basics. Pretty boring if you're using DSC already. Task number 2 is talking about how to manage configuration data using that concept in YAML files with an hierarchical structure. And it's not only about giving you an idea about how this structure works, but you are also manipulating the structure. You're adding another layer, you're adding another node, you're adding even another configuration to it. And finally, task number 3 is putting this all into a release pipeline and make sure that the changes are actually affecting the service. So then you can kind of recap this all on your own pace. And so if we want to do a change in our environment, let's say we want to have a folder being created on all our file servers, then what I do, and you see I have done this a couple of weeks ago at the NIC conference and set this folder to absent, so we can remove this and say we have a PSCon folder here. And the type of it is a directory. That's it. Okay, change done. I have saved it, and we have in our source control now a changed file, which is my file server YAML. Usually I would have created a new branch for that, right, and then use a pull request to merge the branch into my main branch. For time's sakes, we are doing it a little bit quicker. And edit folder for PSConf. Okay, so that's my change. And I'm committing it locally. First, I should have built it, right? As we said, feedback loop, build your stuff locally first, see if things are working. And hello, PowerShell. And this solution comes with a single point of entry for building your artifacts. It's just build.exe. It automatically downloads all the dependencies. So you may know if you want to create a MOF file, you need to have all the DSC resources in place. And this can be sometimes a little bit tricky. And thanks to this PS depend solution, we know exactly what resources we need to have. We are downloading them from whatever source you define. And then we are creating RSOP files. For those of you who are dealing with or have dealt with group policies, in Active Directory, we can have group policies on multiple OUs and multiple layers. So I remember back in 2000, Windows 2000, long time ago, there wasn't any RSOP, resultant set of policy technology. So you had no idea about what effectively comes to the client. So you need to go, or had to go manually to the OU structure to figure out how many policies is the client getting and how could these policies be merged together. So this is why we are creating an RSOP file here to kind of merge all these YAML files into one big file per server and give you an idea about how the final configuration looks like. And at the beginning you have seen we are using a bunch of pester tests. Here they are. So I said fail fast. We immediately want to see if our configuration data doesn't make sense. For example, let's add another node here. I'm just copying the file and give this another name. So this is my file server. There is already 10, file server 11. Okay, and let's build again. Okay, something in red, good. And what happened is no duplicate IP address should be used, right? So if I have done a logical problem or I've introduced a logical error in my configuration data, I would like to have immediately a response that things don't make sense anymore and the build process is failing locally, right? So usually, this doesn't always work that simple, right? But if you are introducing a kind of bug, a problem, and unfortunately, because we didn't have a test, we are kind of propagating that problem to our test environment and prod environment, then we should make sure that this is not going to happen a second time. So what can we do? Writing a pester test to make sure that the next time we are catching this error just locally or at least in the CI/CD in the build process, right? So let's fix this problem, and fixing it works like giving it a different IP address. I have no idea what IP address could be used. Let's do the 200, 210. And next time, things should work. Yeah, so this is my first kind of testing phase. And if we go into Azure DevOps, no, on this machine, if we go to Azure DevOps, then we should see that in the release pipeline, exactly the same thing happens as locally. No, it didn't, because I didn't push it. So let's push the change. This was the change regarding adding a file to a folder to the file servers. And here we go. Build process started. So in an ideal world, what would be required from the administrator, from you, in order to make this change being effective after having it checked into your code repository? What? That's it, right? Yeah. So the answer was just a manual approval before you're going to prod, nothing else. So we should automatically now, or we should just be able to wait until this change gets promoted into our dev environment, test environment. Then we should have some tests in place that automatically make sure that everything is according to our plans in the test environment, and that's it. And then somebody finds an email in its inbox saying, do you want to promote this change also to your prod environment? That's it, right? And then we know that we have exactly done the same change to all three environments without any human interaction. Because, remember the quote, the pipeline is doing its work in an unemotional, rigorous way, regardless of the environment.
Well, argue that it's good to add pull requests to the first step as well.
Right.
So that somebody looks at your changes as well. Because
yes.
Just because they doesn't necessarily mean that they are good changes to do.
Patrick's comment is very good. As I said, due to time constraints, we are doing everything in the main branch. Usually, you would create an extra branch. Then you would create a pull request, and the pull request, according to your pull request policies, requires maybe 2 approvers. People that are reviewing your change, knowing about the change, can maybe ask some other people who might be affected by the change, and this gives visibility. It's all about traceability, visibility, and working as a team, right? And if you do something directly to main, it's kind of a big violation of all standards that we have. And I think in most companies, please. Of course, the bus factor again.
They know how to do things because they see how you did it.
Yeah.
So next time they can do the same.
Yeah, yeah. So that's also a good comment. A pull request is also a kind of teaching other people how to do a change, right? Because if somebody reviews my change, then this guy would know about how to create a folder on a certain level in the configuration, right? So the next time, maybe I'm not even required because somebody else can do the change without me. Yeah. Limits the bus factor. Okay, so we see the build is running, and this takes, I think, a couple of minutes. It's already compiling the DSC configuration. And what happens afterwards is it publishes all the artifacts into the Azure DevOps database. And then, if we go back to the description of the pipeline, then we are deploying the artifacts to the artifacts share. This is more for debugging and visibility for myself. But we have a deployment process to dev, test, and prod. And this is actually just a copy job. So it takes the MOF files of the respective environments and puts these files to the pull server. And the pull server can be accessed using an SMB share, DSC pull 01. Here are my configurations. And we would see in a minute that the date modified would be updated with the latest timestamp of the MOF files. And then it takes, depending on how the LCM is configured, 15, 30, 60 minutes for the LCM to catch up the new files. And if you don't want to wait that long, you do an update DSC configuration, and then you see that the changes are actually applied to your machines. Right? So that's a very simple release process. Any question on that so far, as long as we wait for the build to finish? Good. Yeah, here we are, waiting for an approval to deploy to prod. So that means that we have already new timestamps for the DSC Web 01 and Web 02. These machines are in my dev and test environment. We see a timestamp is updated. That works as expected. And if I have hit the review button and do an approval here, then we will see that also the prod environment is updating. So if we go to our PowerShell, enter PS session, no, DSC file 01. So no PSCon folder yet. If we do an update DSC configuration, just because we don't want to wait 15 minutes or even longer, then we should see that at some point in time, the folder should appear. There it is. Perfect. Was it there? No, it wasn't here, but here we go. Perfect. Good. Has anybody of you found a good way of kind of closing the feedback loop in terms of having a report that gives you an idea about how the environment looks like? SCOM. Yeah, okay. What about the DSC reporting feature?
I tried it, it doesn't give what I want.
Yeah, I can imagine. Okay, so we extended the database pattern a little bit because the initial 2 tables are simply not enough to get an idea about how your environment looks like. And then we put SQL Server reporting services on top of it. And then we have something like a node overview, and this gives you a, yeah, we have some trouble with the schema actually, but at least one machine is working as expected. So we have a failure, and we have a failure because we are creating a machine on a drive that doesn't exist, right? So at least you have an idea about how many machines are connected to the pull server. Are they in the desired state or not? Or is the LCM currently running? How many resources are configured in total and how many are failing? And you have even a graph that is indicating this kind of summary for the whole environment. That's right. Unfortunately, it looks a bit better. Unfortunately, we have some bug in the trigger, and the trigger is adding some data that results in these unknown states. Right. This is something that we need to fix as soon as I'm back from my vacation. Right. But at least this gives you kind of a very fancy reporting and a very quick view about which machines should be, yeah, kind of monitored a little bit closer or even considered for fixing bugs. Right. So all these resources are publicly available. This one is part of Automated Labs, so the database schema is there. And the script for setup a pull server that is connected to a SQL server as well. Because the nodes are sending the reports to the pull server, and the pull server need to forward the data to the SQL server, right? And depending on how good your database schema is, you can do more or less with the data. Good. Any questions so far regarding the reporting? Good. Let's have a close look, because we're running out of time. Let's have a look at the configuration data. And I think I do this in the slides. So all the way up. Configuration data. You know how DSC works, and you know that the configuration data is just a hash table that we are kind of injecting into a configuration, right? Pretty nice concept, but it doesn't scale, because if you have to create the hash table, you easily end up with huge amounts of data. And I remember we had a Microsoft offering about configuring a SharePoint farm. And if you are dealing with demos, like the demos that we have on docs.microsoft.com, a hash table usually has about, there's one here, about 20 lines of code. For example, configuring a web server, an IP address, and that stuff. The configuration has maybe six lines of code. So here we have 2 roles, a web server, which is doing something on the file system, and a file server, which is doing something similar. But this concept doesn't scale, because if you want to do something more complex, then you're easily ending up with configurations of 2,000 lines of code. And I think this is almost unmanageable. If you want to do a change here and have to go through that kind of structure, that doesn't scale very much. And the configuration data is another 1,200 lines, right? So just for one SharePoint farm, and just for one environment, because there is no way of having this slightly different for different environments. And this brings us to the idea of having a different composition model. So we need to find a structure of configuration data that reflects the real world. And if we think about computer systems, regardless where they are, in Azure, on-prem, we always think about a baseline first. Right? What is the similarity of all the machines? Then what are the roles of machines? Of course, roles capture other similarities. And at the very top, we have exceptions because maybe we need to have a couple of machines configured differently than our official standard. Right? So this brings us to the idea of having layers and if we want, also a merge process, which is merging the different layers together so that we can follow this idea, right? We've heard, if it comes to DevOps and infrastructure as code, pretty often the terms cattle and pets. We want to treat all machines as cattle, so we want to have as much similarities as possible. But sometimes we have systems that are a bit special, that have this pet character, and then we need to be able to define some of these exceptions on the very top of the pyramid, right? And this model gives us the chance that we reduce the redundancy that we have dramatically. And another way that another feature that we have implemented, or Gale implemented, is kind of implementing puppets, roles, and profiles concept into DSC. So that means that we are using I always explain it from the other way around. That means that we have configurations, and the configurations are these ones. These are composite resources, and these composite resources are an abstraction layer between the configuration data and the DSC resources. Because if you have a look back into what we had here, here we are, where are we? Roles. Here we are configuring a bunch of files and folders. And you may remember that the file resource in DSC only accepts one string. So you can talk to the file resource and tell the file resource, please create this particular file. So how do you translate from a list of files without having a for each statement in the YAML files, because YAML doesn't support for each? So how can we go from a list of information in YAML to a number of instructions in the MOF file? So we need to have some translation layer, and the translation layer is the configuration. And the configuration for files looks pretty simple. It is required modules, config demo, just this one. So it gets a hash table, which is the files and folders in my YAML file. Then it runs through all the items in the YAML file, or in the hash table that we have received from the YAML file, and then does some extra stuff, which is not important now, and then it does a DSC splatting. So if you know how splatting works in PowerShell, it's just the same thing for DSC resources, so that we don't need to pass the parameters one by one, but can just splat in this case it's permissions, but where is it? Here. Just splat the items to the DSC resource to make it a little bit more simple, right? Yeah. So this concept is impossible to explain it in the remaining 2, 3, 4 minutes. So if you are or if you think that this whole concept has some potential for you, I would like to encourage you just go to the DSC workshop website on GitHub or on the DSC community, you find the references there, and then play a little bit with the exercises. So it shouldn't take more than 2 or 3 hours, but then you have a decent understanding about how things work. And not only how you can manage and extend the existing configuration data, but also how you can add new layers. Because what we have here is a configuration that looks like this. And maybe your configuration or your requirement is a bit more complex. So here we have just 2 baselines, then a security baseline, role, location, environment, and finally the node. So this is the resolution precedence. But maybe you have something extra like fire sections in a data center, or you have some major and minor locations if it comes to countries. Or you don't need that stuff. Maybe you only have your baseline, the role, and then finally the node. So this is pretty much adaptable towards everyone's needs. Yeah. And what we introduced lately is also some dynamics in the configuration data, because let's go to, So if you see stuff like this, it's not yet very well documented, but that means that you can have PowerShell code in your YAML files. For example, if we are having a look at the node name, Every DSC node has a name property, right? And what we do is we are just linking the node name to the name property. If you want to join a machine to Active Directory, you need to specify the name again. And this caused a lot of redundancies. And now we can just have a code block that is accessing data in our YAML structure to remove the redundancies and give you more flexibility. So every time you see this x equals something, it means code inside YAML, which gets invoked by the data module, and then the result of that code block is put into our result set of policy file. Yeah, so I think this brings DSC to a very different level, because at the end, you don't need to understand how DSC works. So if you have implemented this kind of solution, people only have to deal with the YAML files, and the YAML files are pretty easily to understand also for non-IT professionals. And I have a couple of customers who are giving a front-end access, so just the access to the GitHub or to the Git repository, even to some first-level people, in order to install software, so mostly Chocolatey. And yeah, if someone is just adding another entry into Chocolatey, kicking off the build process, and everything else is then going according to the pipeline. So you don't need to be an IT expert, and you don't need to understand DSC if you follow this concept, because you're abstracting DSC completely away from the configuration data. Yeah. Next step of this solution is going to be, yeah, at the moment we are supporting DSC on-prem and Azure Automation. And of course, the next logical step is to follow guest configuration and to see how this can be used to also organize things in this space. We haven't started yet, but this is on the roadmap for the rest of the year. Yeah, that's it. This was my content, and ready for Q&A if there is something that you would like to ask. Please.
So with the artifacts, so in our environment we don't have completely separate domains. We've got like a test file, like dev file, and they're all in the same domain. So they have like different node names. So I can't promote the exact artifact through. It'll be like sort of a different one. Am I just expected to compare the RSOPs? So I've set up a page for the DSC workshop already. One thing that's trying to manage like the last run of RSOP and the differences between our last one changes and that.
Yeah, we wanted to have some kind of MOF comparer who is comparing that. But I mean, the RSOP files are, they look like this. Let's collapse this, output, RSOP. Here we go. So the RSOP file is just a YAML file again. So if you want to compare, that should be pretty easy, pretty straightforward. But we don't have a ready solution for that at the moment. Yeah.
Following on from that, with the if you have lots of nodes, so when I was testing it out, I've got quite a few extra layers for like platform, various other bits and pieces. It gets quite slow, so it can be many hours to do the full local build process for 4,000 nodes. Is there any tips like improving that speed?
How many nodes do you have? 4,000? Yeah, so we have, so the biggest customer that we are dealing with has 55,000 nodes, and the build process takes actually months. But what we have in the release pipeline, or in the build script, is up two parameters, and do we have them here?
Yeah, there's sort of a follow-up from that as well. I've seen you get some filtered configuration data.
Yeah, but I'm missing something here. There's the filter. Oh no, we have changed the concept. It's just an environment variable. So we have two environment variables that you can configure on your build system. And these environment variables are defining how many workers the build machines should spin up. So this customer is having 128 machines that are doing the build in parallel. And the build script is just taking the chunk that is assigned to the respective build worker, and that speeds up the build process to, I think it's still 1.5 days. Yeah. But if you have 4,000 nodes, then it's definitely something that you can do with this parallel build process. Are you building the stuff on Azure DevOps? Or?
No, so well, this was locally on my laptop, and then we've got TeamCity. We were looking at Azure DevOps.
Yeah. But TeamCity has the same concept of doing build workers in parallel. I'm pretty sure it does, right?
Yeah.
Yeah.
I didn't see like chopping it up, but I wasn't using Azure DevOps, so I just lumped it all in the same build.
Okay, so I think we have it here. Is it thread? No, number. On-prem. No, I must confess I don't find it that quickly. It's somewhere here. But so the question initially was, what do I do if I have a couple of thousand nodes? Because the build process then takes extremely long. And we have features added to this long ago that is making the build process in parallel. So if somebody's interested in this and the documentation is too poor, please just raise a GitHub issue on the DSC workshop. And then we are either adding the documentation or answering the issue, how these things work. Any other questions? Please.
As Microsoft is investing in guests, is DSC still a technology that Microsoft still invests upon, or is DSC
That's actually an ideal question for Jody. She's the PM for guest configuration, and as far as I know, we are not investing in DSC at all, right?
So, come to my session to learn more, but we're going to be continuing to build out guest configuration to be able to support DSC at cloud scale, and so we'll be walking you through an example on how to do that using our PowerShell.
When do you have the session? Tomorrow? Or? Today. Perfect. Good. Good. Any other questions?
I wanted to know, because you said that you have 1,000 of nodes to onboard to the Push server. How do you automate that process? Because otherwise it's manually, right?
You mean how do you onboard? How do you connect the nodes to the pull server?
That amount of nodes. Is there a way to automate this?
Yeah, there is no pull without push, right? So if you want to connect a couple of thousand nodes to a pull server, you need to have a couple of thousand metamorph files. And these metamorph files can be triggered or pushed remotely with PowerShell remoting. So connecting 1,000 machines to a pull server is just a second. Yeah, done with PowerShell. Okay, a little bit over time. Thank you for joining the session. And if there are any questions, please talk to me outside.